6 bizarre natural disasters, from a climate-changing volcanic eruption to a mysterious explosion in Siberia. Learn the stories behind 6 weird weather events that made their mark on history. The Year Without a Summer Credit. D. G. Dogliorti. In April 1815, Indonesia's Mount Tambora exploded in one of the most powerful volcanic eruptions in known history. The blast killed tens of thousands of people in Southeast Asia and hurled a gargantuan ash cloud into the stratosphere. As the cloud migrated across the globe, it blocked the sun's rays, chilling temperatures by roughly 3 degrees and causing weather distortions on an epic scale. The following year, in India, Tambora-induced droughts and floods changed the ecology of the Bay of Bengal and helped give rise to a new strain of cholera that killed millions. Europe was visited by drenching rains and persistent cold that brought on famine and widespread civil unrest. In the United States, heavy snows fell in some states in June, killing crops and triggering an economic downturn. New Englanders later nicknamed 1816 1800 and froze to death, but it became better known as the Year Without a Summer. The weather disruptions had some unusual side effects. Some have credited the high price of horse feed in Europe with inspiring German inventor Carl Dreis to build an early version of the bicycle. In Switzerland, meanwhile, the gloomy weather and constant rain of 1816 forced author Mary Shelley to pass the summer indoors. She entertained herself by penning the famous horror novel O Frankenstein. The 1859 Carrington event, Aurora Borealis, similar to the kind seen during the 1859 solar storm. Credit: Frank Olson, Wikimedia Commons. Solar flares occur when pent-up magnetic energy in the sun's surface is unleashed in blasts of radiation and charged particles. The resulting explosions are equivalent to the force of millions of hydrogen bombs, and the solar winds they create have the ability to wreak havoc on Earth's atmosphere. That was precisely what happened in late August and early September of 1859. When the planet was bombarded by the largest solar storm on record. The so-called O-Carrington event, named for the British astronomer Richard Carrington, made the skies glow with shimmering, multicolored auroras as far south as Hawaii. In Colorado, it was so bright that one witness reported people could easily read common print at night. The light show might have been beautiful, but the geomagnetic disturbances that came with it brought down telegraph systems around the globe. Torrents of sparks shot out from some telegraph machines, starting fires and giving their operators painful jolts. The atmosphere was so charged with electricity in some places that technicians found they could disconnect their telegraph batteries and still transmit messages. The O-solar storm of 1859 passed after a few days, but scientists predict that if a similar event occurred today, it might send telecommunications into a tailspin and cause trillions of dollars in damages. The 1874 Year of the Locust, illustration showing locust plague in Kansas. Credit: Kansas Historical Society. Crop-destroying locust plagues were a common occurrence on the late 19th century American frontier, but most paled in comparison to the one that descended on the Great Plains in the summer of 1874. A dry, arid spring had created the perfect conditions for Rocky Mountain locusts to lay their eggs in large numbers. Trillions of them later hatched and laid siege to Nebraska, Kansas, the Dakotas, Iowa and several other states. Witnesses said the locusts arrived in roaring clouds so thick they could block out sunlight for several hours. Upon landing, they gobbled up entire fields of crops, local vegetation and even the clothes off people's backs. "Oh, the air is literally alive with them," wrote the New York Times. "Oh, they beat against the houses, swarm in at the windows, cover the passing trains, they work as if sent to destroy." People tried to burn the bugs with fire and blow them up with gunpowder, but they were powerless to fight so large a swarm. Millions of dollars worth of crops were eventually destroyed in what became known as the Year of the Locust. The U.S. Army was called in to distribute supplies to the victims, but many homesteaders simply admitted defeat and retreated east. Similar plagues would continue to hound settlers during the next several years. They only trailed off in the early 20th century, when environmental changes caused the Rocky Mountain locust to go extinct. The dust veil of 536 AD. Credit: Maynor, Ulstein. Build via Getty Images. In the mid-16th century, a cloud of grit and dust suddenly descended over much of the globe, dimming the sun and causing uncommonly cold temperatures for several years. most dread portent took place, the Byzantine historian Procopius wrote of the year 536. For the sun gave forth its light without brightness broken bar, and it seemed exceedingly like the sun in eclipse, for the beams it shed were not clear. The long winter that followed brought on drought, crop failures and famine around the world. Some scholars speculate that it also played a role in triggering the first known outbreak of bubonic plague in Europe. Despite its widespread effects, scientists are still not entirely sure what caused the global cooling of the 530s. One theory is that a massive volcanic eruption spewed dust into the upper atmosphere and blotted out the sun's rays. Studies of 6th century ice core samples from Greenland and Antarctica show heavy concentrations of sulfate ions released by volcanoes, and there is evidence that there may have been a massive eruption in El Salvador in the 530s. Other researchers point to a strike or near miss by a comet as the more likely culprit. Halley's Comet passed by the Earth in 530, and it's possible that a piece of it may have broken off and created a giant cloud of debris upon impact. The Great Smog of 1952 credit, Keystone. Not all natural disasters are entirely natural. In December 1952, man-made air pollution in London formed into a massive sooty smog that lingered for 4 days, wreaking havoc on air quality. The deadly miasma was the result of a high-pressure system that created unnaturally stagnant conditions. Rather than dispersing into the atmosphere as usual, billowing clouds of coal smoke and pollution from factories gathered over the city and refused to budge. The smog reduced visibility in some places to almost zero. Livestock dropped dead of asphyxiation in their pastures, and scores of Londoners came down with bronchitis, pneumonia and other respiratory problems. Many children and elderly people died, their lungs ravaged by inflammation. Some 4,000 people were killed before the wind finally picked up and blew away the smog, and thousands more may have perished in the weeks and months that followed. Spurred on by the Great Smog of 1952, the British government later instituted the Clean Air Act of 1956, which gave citizens subsidies to convert to cleaner fuels and banned the emission of black coal smoke in certain areas. The Tunguska Event credit, Science Photo Library, Roger Harris. Shortly after 7 a.m. on June 30, 1908, a blinding light streaked across the skies of Siberia and exploded over the Podkamennaya Tunguska River. The shockwave that followed carried the force of 5 to 10 megatons of TNT, hundreds of times more powerful than the atom bomb later dropped over Hiroshima. It obliterated nearly 500,000 acres of forest and knocked people off their feet more than 40 miles away. Amazingly, no one was killed in the explosion, but its effects were felt across the globe. Atmospheric and seismic devices were tripped as far away as England, and for the next few nights, the skies were so bright that people in Asia could read newspapers outdoors. Experts suspected a meteor strike was to blame. By when a Russian expedition finally reached the remote blast site in 1927, they found no sign of an impact crater. Despite the lack of a smoking gun or crater, most scientists maintain that the Tunguska event was the result of a hit from a space rock. One possibility is that it was caused by an icy comet that evaporated upon impact, leaving little evidence of itself behind. Even more likely is that a meteor around 65 to 100 feet in diameter exploded in the upper atmosphere and broke into tiny pieces. Witnesses supposedly reported hearing a noise like stones falling from the sky after the initial blast, and samples of decayed vegetation from Tunguska include high deposits of nickel, iron and other substances commonly found at meteor impact sites.